Hello. In this video, we introduce the process of selecting appropriate model in panel data analysis among between effects, random effects, and pooled OLS models. We demonstrate this step by step using our own panel dataset, the results of which were reported in our article, published in 2025, in Organizational Cultures, an international journal. In our analysis, we employed the between effects model instead of the fixed effects model, as the latter omits time-invariant cultural variables that are essential to our study. Panel data, also known as longitudinal or cross-sectional time series data, is a dataset in which the behaviors of entities are observed across time. To gain a foundational understanding of panel data, please refer to our previous video, titled What is Panel Data and Panel Data Analysis Method. In this video, we will demonstrate how to choose between effects, random effects, and pooled OLS models, using our panel dataset, which includes 750-year observations, across 79 countries, over the period 2006 to 2019. Our research aims to examine the impact of national culture on country-level entrepreneurship. The data for this analysis were collected from the Global Entrepreneurship Index reports, Hofstede Insights, and the World Bank's Open Database. In our dataset, because of collinearity, 6 time-invariant cultural variables are omitted in fixed effects model, so, we must use the between effects model instead of fixed effects one. We introduce now theoretically the between effects model, that focuses on cross-sectional variation by averaging observations over time for each entity. Unlike the fixed effects model, which captures within entity variation in term of time series, the between effects model emphasizes differences across entities. This approach is particularly useful when the primary interest lies in explaining how long-term, structural differences between units, such as countries, affect the dependent variable. By leveraging only the between-entity variation, the model provides a broader view of persistent differences that are not driven by short-term fluctuations. The equation for the between effects model is in the screen. The between effects model is appropriate when the variation of interest lies primarily between units rather than within them, and when the panel has sufficient time-invariant characteristics that are meaningful for explaining the outcome. It is also useful when the within-unit variation is limited, or when the explanatory variables are largely constant over time. In random effects model, the rationale is that the variation across entities is assumed to be random, and uncorrelated with the independent variables included in the model. Random effects assume that the entity's error term is not correlated with the independent variables, which allow for time-invariant variables to play a role as independent variables. If we have reason to believe that differences across entities have some influence on our dependent variable, then we should use random effects. An advantage of random effects is that we can include time-invariant variables, such as national culture of countries. In the fixed effects model, these variables are omitted, because the model relies on within-entity variation over time. In random effects, we need to specify those individual characteristics that may or may not influence the independent variables. The problem with this is that some variables may not be available, therefore leading to omitted variable bias in the model. And the pooled OLS model is the linear regression. Pooled data occur when we have a time series of cross-sections, but the observations in each cross-section do not necessarily refer to the same unit. In panel data, pooled OLS model can be used to derive unbiased and consistent estimates of parameters, even when time constant attributes are present, but random effects model will be more efficient. Between effects model is a feasible generalized least squares technique, which is asymptotically more efficient than pooled OLS, when time constant attributes are present. Random effects model adjusts for the serial correlation, which is induced by unobserved time constant attributes. For a panel data, we must justify our model choice among three ones: pooled OLS model, random effects model, and fixed effects model. The process of selecting the regression model for panel data is discussed in researches of Doherty and Torres-Reina, as depicted in this figure. In our case, the fixed effects model omits time-invariant cultural variables through within transformation, making it unsuitable when such variables are theoretically important. The between effects model, by contrast, preserves these variables by relying on variation across entities, rather than within entities over time. When replacing the fixed effects model with the between effects model, the Haussmann test remains asymptotically equivalent to testing for systematic differences in coefficients, specifically, between the between effects and random effects model. The process begins by assessing whether the observations represent a random sample from a given population, that is, a subset of individuals randomly selected by researchers to reflect the characteristics of the entire group. In this first step, if the observations are indeed a random sample, we proceed to the next step. Otherwise, the between effects model, in place of the fixed effects model, is employed as the final specification. In the case of a random sample, we proceed to the second step by estimating both the between effects and random effects models. We then compare these models using the Haussmann test, where the null hypothesis states that the random effects model is preferred over the between effects model. If the Haussmann test indicates significant differences in the coefficients, the between effects model is selected as the final specification. In contrast, in the third step, the Lagrange multiplier test is used to determine whether the random effects model or the pooled OLS model is more appropriate for the analysis. The null hypothesis of the LM test is that the variance across entities is zero, meaning there are no significant differences across units. Specifically, if the LM test indicates the presence of random effects, the random effects model is chosen, otherwise, the pooled OLS model is selected as the final specification. Now, we apply the process outlined above, to select an appropriate regression model for our panel dataset. In the first step, our sample can be considered a random sample, due to the time span and global country selection based on data availability. Therefore, we proceed to the second step in the model selection process for panel data, where we estimate both the between effects and random effects models using Stata. Before running these models, it is necessary to declare the panel structure in Stata using the command xtset. To handle panel data, click on Stata's menu as shown here. In this case, ID represents the entities, that is countries, and year represents the time variable. Or, you can type the command here and enter. Note that Stata distinguishes capital letters, so you must type exactly the variable name. As the panel data has been handled, we can now run the between effects model, using the Stata command xtreg, with dependent variable GEI and 8 independent variables. Note that, because of collinearity, 6 time-invariant cultural variables are omitted in fixed effects model, so, we use the between effects model instead of fixed effects one. Type the command here. Note that, the option B should be chosen for the between effects model. Or, you can click this command on the status menu for avoiding typing errors. To compare the results with random effects model that will be performed later, we must save the estimates with between effects regression, using the command estimate store between. Type the command here and enter. Now, we run the random effects model, using the Stata command xtreg with the same variables, by choosing the option re. Unlike the fixed effects model, the random effects model allows for the inclusion of time-invariant variables, as it assumes that individual specific effects are uncorrelated with the regressors. Type the command here and enter. Or you can click this command on the status menu to avoid typing errors. Also, we must save the estimates, using the command estimate store random, by typing the command here and pressing enter. For comparing between and random effects models, we perform now the Houseman test by typing Houseman between random with sigma more option, which specifies that both covariance matrices are based on the same estimated disturbance variance from the efficient estimator. Type the command here and enter. The Houseman test yields a chi-square statistic of 32.66, with a p-value of 0.0001. Therefore, the between effects model is preferred for this analysis. However, the warning that the variance matrix is not positive definite implies potential issues with the robustness of some variance estimates. So, we continue to perform the robust Houseman test by typing our Houseman between random with cluster option, which adjusts for within-country correlation, ensuring robust standard errors and valid inference in panel data. The robust Houseman test yields a chi-square statistic of 8.65, with a p-value of 0.373. This result fails to reject the null hypothesis, suggesting no systematic difference between the between and random effects estimators, when accounting for within-country clustering. In contrast to the standard Houseman test, which strongly favored the between effects model, the robust Houseman test indicates that the random effects model may be appropriate under clustered error structures. In the third step, we check the presence of random effects, using Briousse-Pagan Lagrange multiplier. Because Stata stored the recent results of certain regression, we rerun the random effects regression, then type the command xtest0 and press enter. We can see that the result of this test is significant, indicating a preference for the random effects model over the pooled OLS model. As the robust Houseman test has eliminated the between effects model, and Lagrange multiplier has refused the pooled OLS model, we select with confidence random effects 1. Finally, we must check the heteroscedasticity test for the selected random effects model, using the command strigay. Type the command here with the appropriate variables and press enter. You can learn more about the command by running help strigay. The results from the Lagrange multiplier, likelihood ratio, and Wald tests all reject the null hypothesis of homoscedasticity at the 1% significance level. This provides strong evidence of panel group-wise heteroscedasticity across countries, suggesting that variance differs across units in the panel dataset. Hence, we use the robust option to correct for heteroscedasticity in the selected random effects model, by typing the xtreg with two options robust and re. Here, we should rehandle the panel data. Then, type the command of random effects model with two options robust and re, and press enter. Or you can click this command on the status menu, to avoid typing errors. The robust random effects model is used to test research hypotheses. The final research findings indicate the significant and positive impacts of IDV, LTO, and IVR, the significant and negative impacts of PDI and MOS, but insignificant impact of UAI on the entrepreneurship of countries. Also, we found that economic growth and economy size influence positively the entrepreneurship of countries, at 95% confidence level. We finish here the presentation. Thanks for your views and subscription to our channel. And see you in the next video.